live. That is pretty cool. Today is 14th of March 2026, Saturday. Shit. Yes, today is Saturday. And before beginning, a quote from Meditations by Marcus Aurelius. Yep. Let's see this one. It says, "Let no act be done without a purpose, nor otherwise than according to the perfect principles of art." So do not just do things without a reason. Have some reason, at least a purpose, I guess. Okay, cool. So today we are going to give a virtual contest. Uh, yep, that will be cool. Let's see. Let's see. This is Division 2, 2 hours long, and I hope to do at least 3 problems. Let's see. Cost of a tree. Let's see how it goes. At least 3 problems. That would be the goal. Yep, with that, let's go start at 13, 50, 57. Cool. Start virtual participation. Okay, and 11 seconds. Okay, we are like almost there. Shit, I do not. Shit. Code force is shit. I do not have the extension which is used for getting the problems. The extension is assistant and vim. Wait, shit. Okay, the contest is going on, and before the shit, I have to download the extension, competitive companion extension. Companion extension. This thing. Add to Brave. Add it. Okay, and pin this thing. Cool. Okay, problem number 1. Problem A. Let's go. Hello. Define a block in a string as contiguous substrings of characters of the same type that cannot be extended either to the left or to the right. For example, in the string A, B, this thing, there are 5 blocks: A, B, C, D, and A. Okay, cool. You are playing a game where you are given a string S of length and you can cyclically rotate the string however you want. Your score is then to calculate as the number of blocks in the first string. Please find the maximum score possible. Wait, what is the score? Okay, you are given a string. We can rotate the string however you want. Your score is then calculated as the number of blocks in the final string. Okay, that is simple. Here it is 4, here 3. Shit, no, here it is not 3 but 4. Yep, 4. Here 2. And can we have 4? Yes, we can have 4 in this example. Okay, can we always have 4? Whenever we have this thing, we can keep these 2 things at both the sides and increase the number of blocks by 1. Yes. We can first of all look at both the ends. If both the ends are already same, then we cannot increase the number of blocks. Yep, then we cannot increase the number of blocks. But if the ends are different and there is a string which has size more than 1, then we can make something happen. Okay, cool. CPP and shit. I should have tested this beforehand, but okay. Vim auto command, okay. Boilerplate. And LSP is not working like at all, which is messed up. Lua, Vim. Shit, wait. plugins, there is the tree setter plugin, which is messed up, which is actually causing this problem. This should work. I'm not using a star here. cpp is a thing. Wait, tree setter, yes, this is taking a contest time. I should have been able to do the first problem by now. Okay, in new Vim people, this is normal day. On this page, cpp, shit, so it is correct. I have to do here cpp. Let me just remove this. Right. Cool, go here. Shit, that is not a prop. GitHub says, of course, GitHub says this. Cool, now it is cool. And what is the input? N, and then the string. Toggle cin and string s, cin s, and after taking in s, we have to see, okay, int res equals 0 for int I equals nope, for int l equals 0, r equals 0, l is smaller than n, l equals r, while r is smaller than n, and sr equals sl r plus plus, and then just res plus plus. Cool. And yep, if s0 is not equal to s dot back, the thing at the end, then we will check something. And the thing that we will check a b number of blocks. We have to maximize the number of blocks. If they are not the same, then only we can change the number of blocks. I think if they are not equal to each other, then we can do res plus plus if there is at least one block which is not we will have a boolean flag, big equals false, and if at any point r minus l is greater than 1, the range is greater than 1, then we'll do big plus plus or big true. And here if this and big, then res plus plus, but no, I think it is good. I think this is good. Is this okay? It is working for the test cases. I guess this might fail. This might fail. This might like actually fail. Let's see how this goes. Problem A, C++, yep, 23. Shit. If this big equals true and increase res if they are not equal to same, and if there is a thing that we can spread. Okay, shit, gamble. Let's gamble. Running on test one will pass. Okay, cool, accepted. Okay, that is a relief. Okay, problem number two. You are given a binary string s of length n. You can perform the following operations on that string. Choose an index I and flip one bit at all other indices except for I. In other words, choose an integer I, and for all j that are not in the right range and which are not equal to I. If they are 0, then set them to 1, and if otherwise set them to 0. You can perform the operation any number of times, but each index can be chosen at most one operation. By at most one operation, your task is to make all bits in the string equal to 0, or report that it is impossible to do so if you don't have to minimize the number of operations. Okay, we just have to find out if it is possible or not. What do we have to return? We have n, then we have the string itself, and it is guaranteed. Then okay, output -1 if it is impossible to transform all the bits to 0. Otherwise, output two lines in the following format. In the first line, print the number of operations, and in the second line, print the indices which we used. Okay, the number of operations, we flip everything except one thing. I think this depends on the number of ones that we have. If the number of ones in the string odd, even, odd, even, odd, even. This depends on the number of ones. Let's say we have some one, the like location of these things do not matter. Let's say we have some number of ones and some number of zeros. We have, let's say, x number of ones and x number of zeros and y number of ones. These zeros are already zeros, so we don't really want to do anything with them, except in some cases where, let's say, we have a lot of ones and only one zero, so we will like preserve this zero. And yeah, is it at any point feasible to choose a one as the one which remains unchanged? I think if we have, let's say, a lot of zeros, then 1, okay, we have a number of zeros and a number of ones. Okay, I don't think it is feasible to choose a 1 ever, so we will always be choosing zeros. Yep. And the number of operations have to be even. The number of operations have to be even. And we can choose a single thing only once, which is like, yes, makes sense. X and y, let's say n is the number of operations. We can at max do n operations where x plus y is equal to n, right? And it does not make sense to do these y operations to choose a 1 ever to remain same and change everything else, because that is not our goal. Our goal is to preserve zeros and to get ones. So yeah, that's it. Screen is stuck. Shit. Okay, that was very stupid. Shit. Shit. That was very stupid. Okay. Thank you for like saying shit. You were like just looking at me. Shit. Okay. I'm sorry for that. Shit. It was horrible. Shit. Okay. I did one problem. Cool. I also set up my new resetter, which was messed up, and also downloaded this thing in the context, in the contest. Shit. It is okay. Now it is okay. Okay, this is the problem we are doing. Hmm. This is the problem we are doing. Here we have a string which has zeros and ones, and like you might have given the contest already, Kakashi. In this thing, we have a string which has zeros and ones, and we can choose any one index and preserve the zero or one at that index and flip everything else. And that is like the operation that we do, and we can do this at most once on every index, and our main goal, final goal, is to switch all the ones to zeros, to have only zeros at the end. And I okay, I guess, okay, shit, that makes sense. If the number of ones, y, if the number of y is the number of ones, if the number of ones is even, then we can one by one choose everyone and it works. One by one choose everyone and it works, like in this example. In this example it works. In this example, number of ones is even. In this we cannot do it, and in this we can do it. We can do it directly by choosing 0, but another thing we could do is just choose one by one, and this works because for all the zeros we are not going to choose any of the zeros, and at the end we are doing even number of operations. So flipping a 0 from 0 to 1 to 0 even number of times just ends us with 0, which is cool. And also we are flipping every 1. Yes, for everyone, since we are going to do one operation on everyone, from the perspective of everyone we are going to do odd number of operations, because at some point we, like, for every one, uh, 0 1 1 0, at some point, if this is our string, we are going to choose this one. And since our total number of operations is even, when we have chosen this one, we are not going to flip this. So we are flipping this total even, whatever even number is, -1 times for this one. So we will be flipping this one odd number of times, which means we will at the end land at a 0. And we can make the same argument for every one digit, every one bit. So they will end up at 0, and every 0 will end up at 0, because we are doing even number of operations in total and never choosing a 0. So that works for even number of ones. But what if there are odd number of ones? What if we have 0 1? Can we ever make this work? Yes, we can make this work. We can just choose this 0, may preserve this, and on the next operation we will have 0 0. Cool. And if we have 0 1 0, can we make it happen here? If we choose this 0, we will have 0 0 1. But we have not done anything here. Shit, we just legitimately like changed the position of these two and nothing happened. Okay, right. X and Y. Let's say when Y is odd, when our Y is odd, we do, if we choose something from Y, the new number of zeros, if we choose something from Y, and the new number of ones, the new number of zeros would be y minus 1, all the ones will become zeros except 1 1, and all the zeros will become 1 except 1. So this would be the new distribution of zeros and ones, and this does not actually help. The number of zeros is this, as is it lower? The number of zeros, if the number of zeros was a lot, then like greater than y, then we have more ones than we had before. Let's say if the number of ones was a lot, this is odd, and then we chose a 1. In that case, shit, if we do not have even number of ones, we can make even number of ones after one operation. Shit, yes. I guess, yep. If we do not have even number of ones, we can make even number of ones. But in this case, we cannot make even number of ones. In some specific cases, I guess we can. I didn't give this contest as well. Let's give it now. So the problem is solved if the number of ones is even. If we do not have even number of ones, then we can make even number of ones. X and y. How do we make even number of ones? Our problem is that y is odd. Y is something like 2m plus 1. Y is like 2m plus 1. Y is odd. And x we do not know. So let's say we choose a 1. In that case, the number of zeros and the number of ones in the next iteration would be x plus 1 and 2m 2m 2m, yep, 2m. And this gives us even number of ones if x was odd. If x was odd, okay. So again, the problem is solved if we have even number of ones with x being odd. But if x was even, in that case this would be odd again. But now shit, this thing is even. We can choose a 1 again, and in the next iteration the number of shit, this is even. This shit, yep, this is always going to be even. Yep, if x was originally even, and if we choose a 1 from here, we will have 2m plus 1 and x number of this. Okay, so yep, no net change here, right? So let's say if x is even and y is odd, that is the only case which is like left remaining. We don't know how to solve this one. So if we choose something, zeros and ones, some 0 from this x, if we choose some 0 from this x, let's say we choose, yeah, then in the next iteration the number of ones would be x minus 1, and since x is odd we can write it as 2m minus 1 or 2m plus 1. So in the next iteration the number of y's would be 2m. This extra 0 does not change because it is preserved. That's why. Yep. So even now, wait, shit, now the number of y is even, which is good. The number of y is even. And now we can solve it. the number of y is even, and this was the case when x was odd and y was x was even and y was odd. For example, 1 0 0, if we apply our same solution here, this one, so let's say we choose this and we will get 0 0 1. Shit, I guess I missed something. Shit, this is even, right? Fuck, yes, this is even. So even is 2m, so we will here have 2m minus 1, which is odd, and we are not helping. I guess this is the one case where we cannot solve this, when the number of zeros is even and the number of ones is odd. In that case we cannot solve it, and we have a solution for every other case. Cool. Let's do this then. CPP boilerplate n, and look at this thing. This thing, ranges, is a thing that I wanted to use. I want to make a post about this, but this is like more, I do not just want to make a post about this because this is a long thing. This depends on iterators and like iteration, then pairs, then views, then spans. This is spans. This takes into account quite a few things, so I do not want to make a like simple post about this. I think it depends on whether we can make both number of ones and number of zeros even after some operation. Number of zeros does not matter. Number of zeros only matters when the number of ones is odd, and when the number of ones is odd, we do one operation on 1 0. We do one operation on 1 0. Shit, wait. Let's say we do one operation on 1 0, we get 0 0 0 0 0 0. The remaining zeros would be it, which simply means, shit, in this case we are just doing operations whenever there is a 0, and when we have a number of ones as even, we do operations on all the indices which have ones, and it works. Okay, and C1, count of 1, I think we can just do C S, or let's use ranges. Can we do count? Shit, yes, we can do count, and given S and count for 1. Okay, this might just fail, I don't know. And count of zeros, count in S 0. Okay, if C1 and 1, if this thing is odd, if this thing is even, then shit, we can have a variable find equals initially, let's say 1, and if this is odd, if the number of ones is odd, then look if number of zeros is odd. If the number of zeros is odd, then it only depends on the number of ones. Yeah. Here, if the number of zeros is odd, then find equals 0, else we do not have a solution. We'll say -1. Here we will print the solution, but first of all I want to see if this ranges function is working or not. slash n. Let's see. Okay, it is working. 2 1 2 2 seems to be working. Cool. Now if f and d is not equal to -1, or if f and d equals -1. Wait, we don't even have to check. We can just say here return -1 with backslash n and return legit return. Otherwise, for n I equals 0, I smaller than n I plus plus. First of all, we have to output the number of operations. The number of operations is going to be shade count of count equals 0. Count normally would be equal to c1, and in this case count would be equal to c0. Here output count with a new line, and if si equals find the thing that we are looking for, cout I plus 1. And then output a new line. Okay. Two. Wait, f and d should not be an integer. It should be like char. Makes sense. And here 0. Okay, 2 1 3. This is correct. This is like correct, no problem with this. And here it says 0, which is so cool. We should not be printing this random new line here. If cnt yes, that works. Yep, no random new line, and 1 and 3. Like in, yep, just do the operations on the ones and we are okay. Hopefully we are okay. I do not like the quality of this code because we are conditionally printing new line. I do not like that. I really do not like this. Okay, so instead of this, we will, after every operation, we will do cnt minus minus cnt before every operation. Here we will do cnt minus minus, and here we will conditionally print space on new or new line depending on cnt. If cnt equals 0, or if not cnt, then print a new line, otherwise print this. Makes sense. But what if cnt is actually 0? Then also we need a new line. We do not need a new line here. I guess now, yep, more things so fit. B compiler is also cool. Okay, I do not want this to fail. Very, let's see. This took like 33 minutes to write. Why does it say 30? Yes, this did took 33 minutes. Okay, it is just like thinking in queue. We can begin on to the next problem. All in one go is the next one. Shit, I messed up. I closed my browser. Shit, the stream is going on, which is cool, but I closed the browser. I'm just learning this, how to use this aerospace thing. Yep, cool. This is workspace something. Move this to 3 here. You are seeing all the stats. And we do this. Yep, cool. We do this. All in one go. You are developing a new shooter game, but since there are a lot of shooter games out there, you decide to have something unique in your game. You have an all-in-one gun that shoots bullets in a fixed order. There are n bullets in the magazine, the ith of which deals AI damage. You have an all-in-one gun that shoots bullets, uh, all-in-one gun all-in-one gun that shoots bullets in a fixed order. There are n bullets in the magazine, the ith bullet of which deals AI damage. The enemy starts with health H and dies when its health becomes less than or equal to 0. The gun shoots one bullet per second. After firing the all n bullets, it must reload, which takes k seconds. Reloading always restores the same sequence of bullets from A1 to AN. You cannot reload early. You must empty the magazine first. At the start, the magazine is already full. Before the light begins, you may perform at most one swap. Pick any index I and J and exchange AI with AJ before the fight begins. Okay, your task is to find the minimum number of seconds needed to kill the enemy, taking into account this optional single swap. Do we get this swap after every reload, or this is just for the first thing? At most one swap. Okay. Your task is to find the minimum number of seconds needed to kill the enemy, taking into account this optional single swap. So we would like to do a swap if we can make this thing more descending. Okay, what do we have? We have N, H and K seconds. H is the initial health of the enemy. This thing, the size of magazine health of your enemy, and time required to reload the magazine. The second line of each test case contains N and it is guaranteed. Cool. Okay, we want the sum to be equal to this thing, and minimum number of seconds. We want this, I guess 3 for this first one. 3 is the correct answer. Cool. And then for this 2 seconds. 2 seconds. Cool. And then for this one, shit, we will have to go through the whole thing at least once. And yes, so we will see if we can kill the enemy in one go. If we can, then we would like to put swap. We would like to do a swap. And what is the maximum value of n to power 5? Okay, this is a cool thing. 6 seconds. 1 second for this bullet, 1 second for this, 3 seconds of delay, and then 1 second for this bullet. This would have been very insightful if the order was 1 2, but okay, this is also cool. Is this okay? The total sum here is 6. So we go through this, takes 3 seconds, then 5 seconds of delay, 8 total. 3 more seconds, 11 plus 5, 17, and we have dealt damage 12 till now. And we have to go through this whole thing again. 3 more seconds after 17, 20. Shit, it is 19. How? 1 2 3 plus 5, 8, 9, 10, 11 plus 5, 16. Shit, yes, 16 plus 3 is 19. My bad. And 10. So we have to go through this whole thing, which is 6 seconds. Now this is insightful. 6 seconds, 10 second, 4, not 6 damage. Remaining damage is 4. To do that 6 damage, it took 4 seconds, 4 gunshots, and 4, and then 10 seconds here, 14, 14 plus, and 4 damage is remaining, so we have to go to 3. 14 plus 3, 17 is the answer. I do not understand the swap thing. At most one swap. Before the fight begins, you may perform at least one swap. Exchange AI with AJ, but does this thing like remain? The first you swap the bullets. Yep, this makes that. Okay, shit, we are changing the array A itself. Okay, I guess, and that thing remains through all the swaps. Okay, we got this. Cool. Well played. And N, H, and A. H and A. And cool. And then vector A size N0 for int reference x. It feels so good to write C++ after a long time. Okay, fill this array. Cool. Long sum equals ranges. Sum, can we do some? Shit, we cannot do sum. Ranges does not have a sum function. Shit. Ranges does not have a sum function. Shit. Okay. Then sum should accumulate. Okay, there is no accumulate function in ranges. Accumulate, or maybe it is here, but can we just say A here and give 0 long? No, we have to do dot begin and A top end. Okay, we have the sum, and if sum is smaller than H, and we should also look at the ranges. Ranges are almost at the cusp of breaking out. If H is greater than SM, S equals 0, we will go through the whole thing, number of times, whatever that base number of times is, let's call it base, and then at, we don't even have to do this, we can just say base equals H divided by SM. Yep, which is correct. H divided by SM, and then base H divided by SM, E multiplied by H divided by SM. Not just key, multiply this one cycle. Yes, one cycle takes k plus n seconds, and there are going to be h by m cycles. So h by m into k plus n, that is the number of cycles. Yeah, base time is this. And then the last cycle, you have to optimize for the last cycle, and for the last cycle you can say h minus the remainder, h remainder. Can we do this? H remainder with the SM. Yes, we can do this. We have to take, we have the ability to swap. Why do we wear headphones while coding? Stereotype. It's just a stereotype. They are not doing anything. Living the meme or something. Okay, h remainder sm. Okay, now the problem is this. We have some number which we want to get as a sum of these numbers, but we want to include as few numbers as we can, and we have to begin from the start. The one thing that we have that we can do is make a swap, like swap one of these later numbers with one of the earlier numbers and reach that sum earlier. So that is pretty cool. Like here, if we were not to change anything, then we will reach the sum which is equal to or greater than 10 after 4 elements. But if we were to swap this 2 and 5, we would reach the sum after 3 elements, which would be 4 plus 5 plus 3. Okay, which would be 12. I guess we just go forward, reach the sum, and then we want to do one swap. We want to do one swap. And swapping a smaller number is not good. I Swapping a smaller number is not good. Okay, figuring out which two numbers to swap is the main problem here. And let me also send this here. Shit, your message got deleted. Hello. Which two places to swap? And it is not guaranteed that our new number of elements after swapping that reach the given sum is going to be one less than the original one, because like maybe we might have a number 100 here which we can swap with the first number, which will like after just one element get to this sum. Mhm. Okay, but what we do know for sure is the swap that we are going to make. Okay, shit. Okay, makes sense. What we can do is, let's say in our array, we want to get to a sum of h. Let's say we are getting to this sum h after going through these elements, right? So we now want to make a swap. What we can do is we can find the maximum element in this range mx and start going backward from this last element in this green range, and we will swap this element with mx. That does not help. We will go back and we will keep track of the maximum element. We will start to increase this range. Mm, Shit, this is more difficult because maybe making a swap here reduces this range from like this to this, which is helpful. But how do we get to the relation of this to this? But what does the swap essentially means? Essentially, a swap means that we take a smaller number from this green range, take a smaller number from here and exchange that smaller number with a bigger number from later on, which means let's say this number was bg for bigger, this number was sm for smaller. Essentially, swapping means we increase our sum by bg minus sm at this point. So this is an advancement delta what we are getting. Hmm. bg minus sm. Okay. Shit, 2000 people have done this problem. Shit, we can even see the standings and stuff. Virtual contest. Not very good. Standings are not very good. Shit, why are like people with no rating here? Crazy stuff. All in one go. All in one. We can though. Shit, I think we can use binary search here. I think we can use binary. Can no, we cannot use binary search. But you know that we have to take some big number from, maybe shit, maybe we don't even have to take a big number from here. Maybe we might have to take a big number from like the end part of this array and put it here. That might also help us get to the desired sum earlier. But one thing that we do know is it is always better to pick a bigger number from later on to bring here. We might, yep, to pick a bigger number to get here. And we do know that in this, the maximum, shit, I think we can use binary search. The maximum range is going to be whatever it is going to be. We will be able to find it, which we already know can get to a sum of h, and let's say it is r, like a right limit, and l is going to be 1, and we always know that l is going to be 0, and we always know that l is never a viable option. Cool. L is never a viable option. So our range consists of L to R, L not included and R included. And yep, given a range between this, in this range L to R, let's say M, can we make a case that we will reach the sum H in this range M by just choosing the first M elements, where we do have the freedom of swapping one big element from later on outside the range of M and put it here in this range of M. I think we can, because we can just find the biggest element in the smallest element in this range M and replace that with the biggest element outside the range of M. And if we are able to get to the sum H, then we are good, otherwise we are not good. Yeah, I guess that is cool. Pre-compute, prefix, sum. Let mxi equals mx. Wait, what? Let maximum sub x equals maximum a I for j greater than equal to I. Wait, what? Prefix sum. Prefix sum. I guess binary search works here. Let me like do this in binary search, and then I will look at your solution. contest. Okay, and L is never like a right option, and R is a right option. So first we have to calculate R, which is going to be, let's have a current sum. Current I, current X, and A. CS plus equals X, and if CS greater than equal to H, break is cool, cool, right? And then our R would be equal to, shit, we do need the index. L would be equal to 0, R would be equal to, let's say, 0 also. And whenever we do add something, we'll do R plus plus. We do this before, yeah, we should do this before here, and we will only go through this whole thing if H is something. Otherwise, just output time. Okay. After this, we do have L and we do have R, while R minus L greater than 1, M equals L plus R minus L divided by 2, and we will have to write a function, boolean, okay, which takes in M vector integer reference A and H, which is an integer, right? And smallest number, or first of all, let's find the sum. Long sm equals a dot accumulate a dot begin and a dot begin plus m in 0 long, right? And right, so we have the sum, and now we have to do the swap. We have to do the swap, for which we have to find the smallest number. Is there a direct function to find the smallest number in a given range? I don't know. Find smallest. We can write a function right now. Yeah, let's write. Next, for I equals 0, I small than m I plus plus sm shit sml small sml equals minimum of sml, or the current number, which is ai, and we also need the maximum mx equals 0 for I equals m is going to be included or excluded. M is going to be included. M is not going to be. M is going to be included. This should go here. Good. Yes. Okay. I equals m, and also this will go till m I equals m plus 1, while I smaller than a dot I plus plus, and mx equals minimum of mx, maximum of mx or ai. Here, right now we have to decide whether to swap or not. If mx is greater than or equal to, if mx is greater than and the small number, we'll do the swap, and swapping just means sum increases by the difference of mx minus sml, and at the end return mx, returns sum was greater than equal to h, or right, cool. And then here if okay, when m and a and h is the thing, if okay, if this number is okay, then r equals this number, else if it is not okay, then l equals this number. And cool, after this we do have this, and r is the right number, p plus equals r. R plus 1, r plus 1, because r is the index, and yep, to get to a index I, you have to spend I plus 1 time. 1, and hopefully this is right, hopefully, but yep, shit, hope misses. 4 3 7 8, and this is like 24. Why is this 24? Second last is says 24. 24, shit, this was 24 beforehand. Yes, shit, yeah, this would be 24 beforehand. Since if h else t minus equals k. Cool. And in the first one, 10 1, this thing says 4. Let's see. T with a little bit of, this thing says 0 in the first go, which is pretty cool. 0 makes sense. And what were the L and R values? Okay, 0 and 3. 4. Okay, 0 and 3. 3 is 0, 1, 2, 3. Cool. And then what was the final R value? Final R value must have been 3. So A 0 and 3, we went to 3 divided by 2, 1, and 1 was not okay. Yep, 1 was not okay, but 2 must have been okay. If when we called this is okay function with 2, 2 must have been okay, because when we were calling this function with 2, that includes first 3 numbers, because index is 0, 1, and 2. And we would have swapped 5 with 2, and we would have gotten a sum of greater than 10, but we didn't. SM and equals 0, SML must have been 2, and MX must have been 5, and SM must have been plus 3, increased by 3. And this should have returned true, but it didn't. Okay. BC 1, 2. Only the times when M was okay. M was never okay in this shit. M was never okay. M2 didn't return. Okay, why did it not? When m equals to output everything. If m equals to cout mx and sm, or shit, there is a print function, by the way, like legit a print function. There is a print function, and I guess we can use this like this: mx sml, or we cannot. Shit. Let's use standard out sm and mx sml. Wow. Okay, shit, this was 6. Shit, this should not have been 6, this should have been 9. Okay, so the accumulate shit, of course, shit. It will be m plus 1 here. Because the last value is not included in the sum. Shit, that was the only thing which was messed up. Now we should be okay. Yeah, now we are okay, cool. Let's see, it's also in fine. Okay, wait, whatever the case, when 4, 1, 5 and h equals 5, answer would be 1, but in your case it would be 2. No, it would not be 2, it would be 1, because r would be equal to 0. R would be equal to 0. Wait, shit. Did shit, and this should be like minus 1, because this is never the possible answer. Now it is okay, my bad. Let's see. Is compile run one test case which where n value is 3, some required sum is 5, second does not matter, and 4, 1, 5, answer is 1. Cool. And if I guess if L were 0, in this case I guess this would mess up. N is 3, 1, 4, 1, 5. Yep, now it is 2. It is because of L. Cool. Now we are okay. Let's see. Because we want L to be never a correct answer, and minus 1 seems okay for that. This one, now we can look at this one. Shit, okay. Vim resetter. Shit. Here's the problem is we are not able to see colors because of the tree setter. We just fix the tree setter, everything would be okay. Tree setter and start is the function. Podium toggle. Podium is disabled, and vim dot tree setter dot start. Shit. There's no parser for CPP, it seems. Okay. I don't think there is any problem with this part. because yep, we have to go through the whole cycle at least h by sm times. Sm is the total sum of the whole array. H by sm times we must go, and each time it takes k plus n seconds because there are n elements to go through them, and k second of delay for reloading and stuff. But there is this crucial difference which must be pointed out, which is if we were able, if like h is a proper multiple of sm, in that case we do not have to go through the last reload time, in which case we do t minus k, we remove the reload time. But not here. Right, after that we make two ranges, L and R. Sum to get to H takes time L to R. L to R, where L is not included and R is included. Therefore, putting his initial value equal to -1 makes sense because -1 is never the right answer. But yeah, the other thing is 0. Since we do know that h is a non-zero value, h is the remainder, h is a non-zero value, so taking r equals 0 at the start makes sense because at least we have to go and take one element out of the array. Swapping or no swapping does not matter, at least we have to take it. Then we do take it and we check if we have reached the threshold, and if we have, then we break. If we have not, then we increase r, we take in the next element and we move on. Cool. Right, and then we see this, we narrow this range, and our initial assumption for this binary search to work is that at some point after some point there is some point m in the range L to R where all the things on the left of L do not give us the correct sum of h, but all the things starting at m to its right give us the correct sum. And I think that is also reasonable assumption. Okay, and we are finding that m, if it is okay if we can reach h sum from the first m elements of a, then we say that r is m, and if we cannot reach it, then we increase r l, which is like basic principle of binary search. But this does not work, and then we increase the time by r plus 1. Something is missing from this. Test case number 3 messed up. Shit. The thing that did mess up might be at most one swap. We can do at most one swap. At most. Does it mean that we can do it at the first time that we are going through the array? Or when can we do it? Maybe we cannot do the swap later on. We will swap bullets present and index 1 and 3 and make it equal to this in the third test case, which is this. Six. Okay, yep, swapping makes sense even if we do go through the list at least once. Okay, completely. So we can swap is our okay function okay? Sum, calculate the whole sum, which is cool. maybe we are maybe we are messing up somewhere. This cs is long, we are not messing up with cs. This comparison is also okay. Maybe we are messing up with this shit. This might be it. We might be messing up with this, in which case it would be cool to multiply this by 1 long. This k plus n will not be very big, and this will also not be very big. That might actually be it, why we messed up, because the logic seems okay. Do we want to like risk it all and see? Long seems to be the mistake, and long seems to be the mistake. Yep. Let's okay, all in. Okay, submit code. Okay, that was the mistake. Okay, shit, that was the mistake. Okay, let's go. Cool. Shit, nice. Cool. Long was the thing. Shit, long, because we were like multiplying big numbers together. Shit, that was the mistake. Okay, what next? 4,000 people. Shit, we like spent 15 minutes on this last submission. Standings, my submissions. Let's do more. How much time did we spend on this? Yep, 9 minutes on just one long overflow mistake. Before and after. This is a graph problem, so it is going to be cool. And shit, the rank right now is 3,000 something, which is not very good. 3,000 not good, not cool, uncool. Firefly bro has solved a lot of problems. Shit, 2 minutes, 10 minutes, 23 minutes. That is cool. Okay, cost of t. What do we have? For a tree t, we have a tree t with root r, where each node u has a value au associated with it, and the cost of the tree is defined as this: the product of every node value multiplied by dru, where r is the root and u is this, and depth, I guess. Here the sum is, what is dru? Here the sum is taken over all nodes u in the tree t, and dru denotes the number of edges in the shortest path from root to node u on a tree. You are given a tree consisting of n nodes rooted at node 1. Each node I has a value ai. Yep, each node I has a value ai assigned to it for each r from 1 to n. Please solve the following problem independently. So we are at different times choosing different nodes as root, which is messed up. Shit. Consider the subtree of node r with respect to node 1. Formally, the subtree of node r is the tree consisting. Wait, let me send this here. Consider the subtree of it. Okay, the value makes sense. You are given a tree consisting of n nodes rooted at node 1. For each node I has value ai assigned to it. For each, please solve the following problem independently. Consider the subtree of node r. Okay, consider the subtree of node r with respect to node 1. Formally, the subtree of node r is the tree consisting of all the nodes u, such that the shortest path from 1 to u contains r. Yep, makes sense. Find the maximum cost of the subtree after performing at most one operation of the following type on the subtree. And we have to do this for each subtree, at most one operation. And what is the operation? Choose a node u which is not equal to r, remove the edge from u to the parent u star, then add an edge, add an edge, add, then add an edge from u to any node v that is still reachable from r. Okay, it can be shown that after this operation the graph remains a tree. Yes, because like we are taking that node u and putting it somewhere else. As an example, in the following, with r equals 1, yep, with r equals 1 we chose this subtree and we attached it here. Cool. And we, oh shit, okay, what does increasing the value in terms of this means? We cannot change au, it is fixed, we cannot change that, but we can change dru, the depth, by putting the tree, a subtree, in a lower place. Okay, by putting a subtree in a lower place, let's say for 2, let's say 2 was our subtree root node, and the subtree is 2 5 6 7. In this case, using this node 7 and putting it as a child of 6 makes sense. That would increase the value of, and I do not think we can make it any better than this. Yep, we cannot make it any better than this, in this case at least. And if 1 was the subtree for which we were trying to maximize the value, in that case is taking this subtree 5 6 7 and putting it as a child of 8 makes sense. Okay, what do we need? We need for each node the sum of its subtree. Yep, the sum of its subtree. Okay, that is something that we will need. And second, whenever we are making this like change, when let's say we take this node 7 and put it as a child of 6, we are increasing the value of, since we, whatever the amount of, we are only increasing this by integer value. So like as a end result, the whole subtree that we are changing height, whose height we are changing, whose height we are decreasing, or like height or depth, whatever you want to call it, we are increasing the depth, we are increasing the value of that subtree by the sum of that subtree that we are moving multiplied by the increase in depth. Like in this case, 5 plus 6 plus 7 is 18, and right now the depth, yep, right now the depth of this 5 is 1 2, let's say the number of edges 2. And shit, if we were to make it a child of 8, then the depth would become 3, in which case we would be increasing the value of this whole tree by 18, which is the sum of 5 plus 6 plus 7. Okay, we at least have a mechanism to think about this. Now we need to find out how to go about this, because we have to do this for every node. I guess it would be cool if we begin from the root, because when we begin, not from the root, from the leaves. If we begin from the leaves, then we have a very few number of choices we can do. First of all, we need to answer two problems. One is which subtree, yep, one is this, which subtree to move, and right, that is the only problem, because where to move it is not as difficult to solve, because we would just put it at the maximum depth we can. Shit, for which we also need the maximum depth. Okay, the things that we need is, one is sum of all subtrees, which is doable by dynamic programming and DFS or something. And second is depth of each node. Depth, we also need depth, and we also need height. We also need height, and we also need depth. We need two things. Depth of the, and by depth we mean the, like, minimum distance between the root node and this current node, and height or maximum distance to leaf node, to leaf. These are the things that we need, and these are the things that we need to answer this problem, which is which subtree to move, If we can answer this problem for each of the nodes, then we are okay. Let's look at this one. Here we have a lot of subtrees. You could move 2, 5, 6, 7, 3, 4, 8. Shit. When we can actually go through all the subtrees, what are the time limits for this? Constraints. Okay, shit, we do have like whole ass big trees. We can actually go through all the subtrees, I guess. Find out when we are finding out the sum of all the subtrees. Let's, since we are going to use dynamic programming for calculating the sum of all the subtrees, that is the sum of all the nodes in a subtree, we can go through all the, okay, let's say first we will go through all the subtrees, and we will find out maximum distance to leaf for each subtree, maximum distance to leaf, and also depth of each node. Yep, we will calculate these two things first, in like first iteration through the tree, and then sum of all subtrees. When we are finding out sum of all the subtrees, let's say I found out the sum for this subtree, we can see, shit, but we are not guaranteed that the tree is like a good tree. We can go through all the parents, all the ancestors of this subtree, and choose this subtree as a valid choice for that parent. But shit, yes, shit. Okay, we cannot just do that because let's say for this subtree 567, if we were to choose this to move for one, we would look at the maximum depth, maximum distance from this one node to a leaf, which would be to 7. But if we were to choose, shit, allow, but my mouse stopped working. Right, it is working now. Cool. Yep, everything is working. Cool. And where did my comments go? Shit, they are not here. Vanished. You are sus, bro. You do it with Archit and now with me. No, no, it is not me. It is YouTube. YouTube is messing up. YouTube is messing up. Hmm. Shit. Here, if we do choose 567 as the subtree to move to the maximum distance to a leaf for one node, for node number one, the maximum distance is 7. But we cannot pick up this thing and put it as a child of 7 because no, that does not happen. This is cool. This is cool. This is cool. Cool problem. 30 minutes. Standing is also not pretty cool right now. Graphs. These questions are valid. Which subtree to choose? But no, which subtree to choose? And with each subtree, there is a different maximum depth that we can choose. With each subtree, there is a different maximum depth that we can choose. Shit. Save to list. Review. Should I lost all of my previous problems which I had put in a list? There are a lot of moving variables in this one. Graph is cool. Let's look at like the next one. Maybe we might be able to do this. I don't know. You are given two arrays A and B, both of length n. You can perform the following operation. Two arrays A and B, both of length n. Choose an index I from 1 to n and swap AI with BI. You can perform the operation any number of times, possibly 0, but each index can be chosen at most 1 operation. Your task is to make a rearrangement of B after all operations and state that it is, or state that it is impossible. You do not have to minimize for the number of operations. What do we have to say? -1, or otherwise output two lines in one following format. In the first line, print the number of operations, and the second line is the indices in order. This one somehow feels more simpler than this. This one actually feels somehow more simpler. First of all, we will count everything up. Makes sense since we cannot move elements within an array itself. Like we cannot swap two elements which are in A or two elements which are in B. We can just switch them between A and B. One check that we have to do is the total sum of elements should be even, like even number of ones, even number of twos, even number of threes, which is true even in this case and in this case, but not here. So we fail here, we say -1 here, right? That is test number 1. Test number 2 is we 10^6 numbers. 10^6 can be the length. Let's say we have a bunch of ones in this and there is a difference between the number of ones in this and the number of ones in this, right? And we must change it, and there are some indices. Yeah, and now like we are doing this next one, which somehow seems easier than problem number D. You should have given virtual contest for 1085. Okay, you will be ranked in. Shit. Okay, yes, you were saying something about this. Yes, I forgot. My friend got 5k rank for solving A in 28 minutes. Shit. Okay, I guess the next one would be 1085 then. And other one got 2.8k. 2 hours. Shit, that is messed up. 2 hours is actually crazy. Contest 1085. Wait, this one. This was the latest. And it was 3 hours long. Okay. And 2 dudes. Ice Serpent is a nice name. Ice Serpent is actually a nice name. 21,000 people gave it, and cool. I will not click on anything else on this one. Shit, that is a nice thing there. Bro was shit candidate master, Duke University, US. Bro has been at it for quite long. Shit, bro had a downfall, but bro was consistent. Okay, problem number D. Problem E. Okay, our check number 1 would be sums should be even, like or not sum, counts of nums should be even. That is like, yeah, test number 1. And after we know that this thing is true, counts should be even, then let's say this is our array 1, this is our another array, and there is some number, let's say there is some number x which appears some number of times in this and some number of times here, and it is appearing more number of times in this array than in this. So we need to do some swaps at these locations where this x number is appearing in A but not appearing in B, and the number of swaps is going to be, let's say the delta is ax, the number of times x appears in A, minus the number of times x appears in B. That is a delta. That is the number of operations we must do at these indices, right? So we have a constraint, we have a set. Okay, and this means we have a set, let's say S of indices where we have to do an operation, and then we can move from x to the next number, whatever it is. Let's say some number x plus 1 which also appears at some indices here and at some things here, and we conclude that we have to do some swaps at these locations. right? And that also gives us a new set, a set for the number x plus 1. To fix x plus 1's problem, we get this set, and to fix x's problem, we get this set. So a better set would be, and also we have a count. We have to choose delta x numbers from this set, and we have to choose delta x plus 1 numbers from this set, and we will have these sets for each of the unique numbers in the whole array A and B, for all the numbers in A and B. Yep, we have this. Okay, first of all, let's, this is just a representation of the information that we get in these two arrays A and B. Before proceeding in this direction of having sets for each distinct number in these arrays, we have to see, is this even viable to calculate this, set and this. I guess it is. We can have a 2D matrix, right, where the key, where we can have a map where the key would be the distinct number x or something, and the value would be a list of all the indices where this number appears. So to get the number of times that this x appears, and shit, this should have two values, one for all the indices in A and one for all the indices in B. So we can have like two maps, which works. Yep, and then the set would be all the indices, right? Let's say the size of this list A is greater than the size of this list B. If it is same, then cool. No. Shit, but shit, okay. These sets, when we create these sets, these do not take into account that maybe when we do go through the with these sets, that will fix this number x plus 1 or x, but that might break some other number. Yep, which is not very cool. We just have to like reduce this set and find a meta set. Shit, oh, we are kind of going into philosophy. Yep, we have to reduce this. Why is this moving with my mouse? Okay, like this is the easy part. Count the number of counts of numbers should be even, but then sets. Calculating these sets is also, at least this filling up this map is easy, not too difficult. And calculating this set would also be easy. Or maybe we do not keep two arrays, but we keep just one array like this. And we go through the list A and fill this up. Or we don't even keep an array, we can keep a set instead. Right, and we will go through A. Our end goal is to find this set which consists of all the indices the count is also important. It is the count important? I don't think so. Shit. We can just ignore the indices where the element in A and B are same. Yeah. We can make our own different list. Hmm. These this one and this problem, they look like they are understandable. Like, yes, I am able to understand them, but finding out the solution is different. Here we can of course ignore all of the indices where A and B have the same elements, which is cool, makes sense. Like here we can ignore this 1 1, right? We can ignore this does not do anything, and then this thing. Mm, okay, okay. How many people have done this? 700 people. Okay. Mm, yep. And D was also difficult. Let's take our luck, test our luck, and try this one. F, fish fight. In a pond, n fishes are in a line. For each fish I, its size is ai, and any fish that eats it grows by bi. Alice picks fish X, Bob picks fish Y. They alternate turns, starting with Alice's fish. On each turn, player's turn, let their fish have size P. The fish will eat an adjacent fish with size Q that satisfies P is greater than or equal to Q. If more than one such fish exists, it chooses uniformly at random among them. Eating increases the size of the eaten fishes pi. Yes, if at the start of its turn a fish cannot eat any adjacent fish, it is instead eaten by its neighbor. A fish at an end point has one neighbor. A fish at its interior has two neighbors. If Alice's fish is eaten either by Bob's fish or by her neighbor's fish, she immediately loses. Similarly, if Bob's fish is eaten either by Alice's fish or by his neighbor's fish, he immediately loses. Given Alice's and Bob's chosen fishes, compute the probability that Alice wins modulo this. Why is probability is like 0 to 1? Why do we need like modulo? More formally, m equals this. The answer can be written as an irreducible fraction, p by q, where q is not equal to 0 mod m output. P, okay, yes, probability is p by q, and we have to do p multiplied by inverse of q mod m. Okay, x y a b 3000. We can go n square. Alice's fish, Bob's fish. Index 2, index 3. Alice's fish is this, Bob's fish is this. So when probability problems are cool. Alice's fish is this. It can eat this or this. And if Alice eats this, which is 50% chance, Alice wins. Right. There are a bunch of scenarios in which one wins. This one also makes sense, but how to actually solve it is again a different thing. Hello, Harrison Dong. Yes, Harrison Ford. Bro, do you have some wonderful virtual contest list? Pete, nope. Just give these virtual contests from Code Forces. Just like, yeah, whatever comes, contest is running. I know contest is running. Whatever contests are there, just give them. That is it. Not a list. Mm. These more difficult problems, they do make sense. Like at least like I am able to understand them. So that much. But the solution. And now I'm trying to think like what goes through someone's mind who is actually very very good at competitive programming. Uh, of course, tourist or someone, Jiang Li, or our favorite person here in catalog, Omnic. What does he see? Abstraction. Abstraction is one thing that they use, like remove all the things that do not matter and just distill to the minimalist thing that we must do to achieve our goal. Or I guess you can call it generalization. Yeah, but I can tell that I won't be able to solve this or the next one or the one after that. Me, but also I cannot say that fully. About this one. Maybe I might be able to solve this. This looks very cool. I guess I will do another stream where I will give more than 1 hour to each of these problems and we will see. After 1 hour, we will look at the solution and actually see how to do these. After spending 1 hour analyzing what we have, what we want, and what we can do with what we have, and can we get to what we want, and what would be the problems in the process. And shit, there is one thing that is common between all these three more difficult problems. It is the brute force solution is not exactly obvious, but after some time we can write the brute force solution. The one that is not brute force is the problem, but I guess that is the problem with any problem. And the total number of ways that we can do things is, these are optimization problems. This is optimization. This is also kind of optimization, going to a goal, achieving a goal. And this one is probability problem. Is there something on CP and book on probability? I have not solved probability problems. Brave is not default. That is crazy. Is there something about probability? Yep, there is calculation events, random Markov chains. Method 1, probability events. Yep, basic stuff. Intersection union about probability. Conditional probability. Intersection. Random variables, the value which changes. Expected value. Distributions. Markov chains. Something. Randomized algorithms are cool. Randomized algorithms are actually cool. Order statistics and graph coloring. We just have to increase our vocabulary to have a better wording to express these problems, and as a result we would have better tools to deal with these problems. Yep, and that just takes time, and right now I'm just yapping. Cool. I guess 4 minutes. That would also be it for today. For today's stream, we did 3 problems, which is cool. This is cool. Not very satisfactory. Statings, not very satisfactory because I took 8 minutes for this one, and then 25 minutes for this, and then a lot of time for this one. And there was a silly mistake in this one which could have been fixed, but I messed up. And it would be cool. Wait, shit, since this is going to end in 3 minutes, we can just look at the solutions submitted by Firefly or someone better. Who is someone better solving these contests? Let's see, did Jiangli give this contest? Yeah, Mass V is at the top. Potato. Okay, Jiangli is not here. Jiangli is a cool person. Jiangli. Here we go. Contests. This is all. And he didn't give 1081. Yep, he didn't give 1081. This is 1081. 1081, yeah. Okay. So now let's look at the solutions submitted by better players. That is how we learn. We will be able to look at the solutions in 2.5 minutes. Cool. What do we do in 2.5 minutes? It is a long time. We can do Wordle for today. Wordle is cool. You can follow. This thing, what is this? This is child. Neighbors. Argentina would be one. Peru would be there, and Bolivia, I guess. Okay, cool. And then capital Santiago. Okay, cool. Where is it? Shit, luck is working today. Okay, this is Uruguay. Brazil. Shit, this might be Uruguay, I don't know. Flag of child, Chile. Shit, random guess. Shit, I thought this was Cuba or something. Okay, Chile, child. Which one of the facts is true about child? Chile, what is the pronunciation?
Geography and climate. 1. Unique shape. It spans over
Pronunciation.
Chile country.
Chile. Shit.
Chile.
Just Chile. Cool, makes sense. It is Chile. Which one of these is true about Chile? And yes, we are doing this Wordle because in 30 seconds we will be able to look at other people's solution and figure out, like, improve our own solutions. So we had something to do while contest was ending. So, like, yeah, we chose this to do. Which one of these facts is true about Chile? Rail transport, don't know. Daylight saving, I guess not. Tourist destination, maybe. Shit. Daylight saving. Okay, shit. Che Guevara. The 1973 military coup in Chile that overthrew President Salvador Allende. Allende brought in General Dash to power. No idea. Che Guevara is not the right thing. Augusto Pinochet. Which of these is Chile? Just guessing. Shit. Chile has deserts? Shit. I didn't know. Atacama Desert. Door to Hell. Atacama Desert. And national emblem. What was the flag? Flag was like this, which has no indication what would be the national emblem. Okay, certainly not this. Federated State of Micronesia. Certainly not this. Is the Hong Kong is also not the right answer. Wait, shit. This one might be it. Shit, okay, that is it. The color of the flag was matching. What are the two most spoken languages? Spanish and second, no idea. This one, Milome, Ilamo, and second might be similar, like this. Okay, it is not. Nimita. And GDP, I don't know if it is rich or not. It is quite rich, 17k. Among Chile, its neighbors, which one has the highest GDP? I guess Bolivia. Shit, Chile has the highest GDP. Bolivia has the lowest one. Shit. What is the estimated population of Chile? Uh, 19 million. 19 million, double than Greece. What is the currency used in Chile? Peso. Okay, out of 19 million, 7 million people live in a single city, Santiago, I guess, in La Florida. Okay, shit. Out of 19 million, 7 million people live in the same city. That is messed up. Which country has a long shit? Bolivia is small with more area. Chile is long. Maybe Chile. No, Bolivia is bigger. Okay, cool. That will be it for this. And now we can look at solutions. Hello. How are you? Just be him. How are your exams going? Let's look at the people's solutions. Here, okay, that is like certainly not a very cool player. Masvi. Okay. What is this? Bro has a very big boilerplate. I do not like big boilerplates. What is this? Wait, shit. This was division 1 problem. Out of competition because yep, bro submitted later on. It, why is this boilerplate like this big? This is very big boilerplate. Shit. Okay. And this is shit. LL taken long n and then a string. Answer is 0. For n, rotate this. Okay, bro, like legit rotated the whole thing. And bro has a rotate function. Is this inbuilt or just shit? This is an inbuilt function. Rotate. Yo, let's go. Shit. That is an inbuilt function. What does this do? This takes in a forward iterator, middle iterator, and last iterator. Okay. C++. I didn't know that there is this function like this. This thing takes in forward iterator, middle, and last iterator. We should get into the habit of reading CPP reference, this thing, which is like unreadable for a normal human being. Let's try. Okay, there are two definitions. One came in C++ 20 and one was in 27 C++ 17. This one returns a forward iterator and takes in forward iterator first, middle, and last. And the second one that, or the first one that came with C++17, this used to take a policy also. So policy based perform a left operation on ranges of elements, a rotation operation, especially standard rotate swaps the elements in range first and last in such a way that the elements in first, middle are placed after the elements in middle and last. Okay, cool. Execution policy to use. This is the definition. Cool. Okay, there is a legit rotate function. And what did bro do with this? Rotate from beginning, and the middle is the element to the right, and rotate till last. So we are just rotating by one element. Okay, and answer equals 1. For after rotating, go through 1 to n, the whole thing. Answer, wait, isn't this n square time complexity? Because we have this outer loop. Yep, and then this inner n loop. So the time complexity should be n square. But that is totally okay because n is 100. So we don't have to worry about high time complexity. Okay. So bro just rotates the whole thing, and this thing is crazy. We go through the whole thing, and if the current element is not equal to the last element, then increase this thing, which is cool. Yep, which is cool because those are the only points. Yep, cool. So this code is counting the number of intersections between different blocks. There might be a block of 1 and then a block of 2s and then a block of 1. So this will increase the count by 2. One intersection would be the intersection between ones and twos, and then the second one would be between twos and ones. Cool. So this is increasing them by this, and initially the answer was 1. So the number of intersections plus 1 to count to get the number of blocks. Cool. This is pretty cool. Let's implement this solution. And yeah, this one. Then take in n and then string, I guess. Yep, it's string, and then for int I equals 0, I smaller than n, small n, I plus. And this thing rotates the vector in place, I suppose. This rotate function. I guess it rotates the vector in place. S dot begin, s dot begin plus 1, and s dot end. Rotate this whole thing and have end plus equals 0 and end answer here. Like we are legit just writing down what he wrote. I smaller than I1, I smaller than n, I plus plus, and yeah, if si is not equal to si minus 1, then answer plus plus. Cool. And then res equals maximum of answer or res, and at the end output res. Output res. Works. Cool. Okay, so from after reading this, we came to know that there is a rotate function, and we got a revision about the fact that we should look at the limits, the ranges that we have been given, because they might allow us to do a brute force solution. Cool. And the next problem. Okay, let's also look at someone else's solution, because mass P has a big boilerplate. This person does not have a big boilerplate. Looks very good. Okay. How did he do it? N, S, N, and S. N equals 1. Checking for edge case. Then count equals 1 if n was not equal to 1. And then start from 1, go till end, and count total number of different blocks. Wait, this is like, yep, this is what we did in our solution, but a little different way of implementing the same idea. Cool, this is cool. Silly star, what did he do? Okay, taking T for test cases, then taking N and S. Okay, he is doing a little bit of optimization here using the same variable, at least the handler S here, to get the string every time. The container changes, but the handler at least is the same. And then ES equals 0, and count all the intersection points. What is this? If Si is not equal to Si plus 1, the next one, or if we are at the last. Okay, that is pretty cool. That is pretty cool. See out union of n or c plus 1. That is pretty cool. They are not equal to each other. Okay, cool. Let's look at the next one. Problem number B. The problem was this. We had to flip, and the solution that we reached is was that if the number of ones is even, then we our answer would be to do one operation for at each index that originally had a 1, and if the number of ones was not even but odd and the number of zeros was odd and the number of zeros was number of zeros was odd, then we would do operations on all the places where there was a 0 originally. So what did they do? Okay, take an n, take an s, db something, and db count of 1. Right, and joe, just some joe variable joe, I equal to 0 smaller than equal to n, I plus plus, and flip if remainder of I is 0. That is a very primitive way of checking parity of a number. If I is even, then I, otherwise n minus I. Okay. Is this the same problem that we did? Yes. But what are they doing with this n minus I thing? Okay, let's say flip. If flip equals db, then jo equals 1, and cout takes in I. We just output I and new line, which is the number of why are we even looking at if the index is even or odd? Like, why does that even matter if the index is even or odd? Oh yeah, I don't get this part. Why does the index matter at all? Shit, I don't get this. Why does the index matter at all? Let's like, it just seems wrong somehow. Why are we looking at the index? Let's look at someone else's solution for this. Long boilerplate. Very sad. 10. Yep, that is more familiar. PBY, PB, what is PB? VI, pushback. Okay, go through the string and yep, have a vector of integers, put all the indices of zeros and ones in those vectors, and if si, size of integer vector, si int x dot size. Yep. If size is even, yep, if size is even, then yep, for put out all the indices of 1. Cool. And else if n is even. Okay, shit. Yes, makes sense. Else if n is even, then put out all the indices of 0. Otherwise, put out -1. Cool. This is exactly what we did. Cool. And let's look at solution for 3. Problem number C. What other people did. Let's see what other people did. Big boilerplate. Oh, not too big. Cool. Multiset. Okay. Taken N, H, K, auto read the vector of size N into A. Okay. And LL is accumulate and answer. Very cool. If H is completely divided by S, then answer minus K, output answer, return. Cool. Otherwise, make H equal to the remaining thing that we must reach. And after this, we did a binary search. Let's see what this person did. Multiset of integers called F. Okay, and insert into F all the numbers. Okay, insert all the numbers. This just does not feel right, because if you wanted to create a multiset of integers with an array, you could just give the starting and ending iterator of the array to the constructor of the multiset, like here, multiset of integers f a dot begin and a dot end. If I'm not wrong, you cannot do this. Maybe this a is not there. The thing we have is s, but s is a string. Begin. Cool. This is like one line way of doing this thing, but okay. Then current equals 0, minimum equals int max. Update minimum. There is a function update minimum. What does this do? If this is smaller than this, then make this smaller than this. Minimum is okay. Current, we are moving towards right. Okay, right. Make minimum equal to the minimum element that we have seen till now. Answer plus plus, increase the answer, right? Because we have taken at least one element for sure. No wonder here. And then current, if current greater than equal to h, yep, then we can just return with this answer. Otherwise, f dot erase some element from this multiset. F dot find ai, find the current element and erase all, no, just erase this iteration of that element. Cool. And maximum, go previous, go to previous, right? Subtract from this. The maximum thing that we can add here is going to be this, I guess. Okay, here we are trying to swap. We raise the current number, yep, and the maximum thing that we can add is the minimum number that we have seen till this point. And f dot end minus minus and the greatest number. But shit, that actually works. This is much better. Yep, and this solution is much better than what we did. Makes sense. This solution is much better than what we did. We used a binary search, but we could have avoided by keeping track of things that we have seen till far, till this point. Okay, let's implement the solution then. Follow blade, move this, int n, h, and k. See, n, h, k, and then the string is okay. And yeah, this is not the one, the number of ones. There's the next one. S equals 0, and what we have to do is n into not n, h is sum. Accumulate s dot shit. This is not a string. Yep, shit, that is stupid. Vector a size n for int reference x in a c in x, and accumulate a dot begin, a dot end, okay, and that is the sum. Yep, and rs would be equal to h divided by sm multiplied by 1 long multiplied by h1 multiplied by k plus n. Right, and if then h equals remainder with sm. Now if not h, if h is 0, then see out rs with cout rs with a new line and return. Else we need to get somewhere. We will create a multiset like we saw. Multiset of integers, ms multiset with a dot begin and a dot end. Here we have our multiset. Long c, or we don't need long int c equals 0 or int I equals 0, I smaller than n, small n, I plus plus. Right, c plus equals ai. Right, c plus equals ai. Yep, we have taken this number and we will do rs plus plus, and also we need minimum equals 0 or int max. Do this and update the minimum. Mn equals minimum of mn or ai. And if c is greater than equal to h, then cout rs, then break. Otherwise, and here and then here's cout s, and if h is there, only do these things, then else do these. Cool. If this, then break. Otherwise remove this element multiset dot erase ms dot find ai, and int mx increase, maximum increase is going to be equal to the maximum number, which would be go to ms dot end minus minus ms dot end minus 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 the minimum number. Now if the current plus mx maximum increase is greater than equal to h, then also break. Otherwise do not break. Cool. Shit. Okay, I will not even look at what went wrong. Just 1 second. Okay, just ignore this. Okay, we are removing the current number, right? And we are finding the maximum increase, which is the biggest element minus the minimum element that we have seen till now, and then break and res also is equal to this thing, small sum remainder with this k plus n cool, then update value of h. Okay, yep, this is like of course wrong. Res minus equals k. Cool, that works. Submit this. Submit for C. It was a boundary error. It was a boundary error. Cool. And but this one is not as efficient as one that we did. That is not the main goal here. Cool. That was cool. That was actually cool. And that would also be it for today. That would be it for today. We gave one contest and did 3 problems in division 3. Cool. And that would be it for today. And thank you for being here.